Hey everybody, I'm David with Bolivar Live. Well, we're here again with Chandra with Aran and Franklin, and we're just coming off a holiday weekend, but we've had a big storm hit down here, Chandra. Hit Florida. We had one hit South Texas that wasn't much, but the Florida Big Bend area got hit hard. Let's talk about the storm. And I asked you before we started the show, how come they didn't have the damage that we had down here? And your comment was it was the storm surge wasn't as high. Let's start
Right.
off with that because people don't realize what rushing water and waves crashing against a house can do.
That's right. So one of the biggest things is that you just really need to know what your risks are. And, there's always, of course, the rain, but one of the big ones is the storm surge. And that's one of the things that we try really hard to design for because we can design for the wind pretty easily and work with clips and straps and shear walls. But the piles have to be designed to a certain design criteria where when they start hitting that crashing wave, the rushing water, debris impacts, floating, the buoyancy and everything, when it starts getting all those forces on it, you have to be able to have all that be taken by the piles, and that's one of the really critical elements in our area. Um, so, like I said, the storm surge for Ike was really high. It was about 16 feet, and most of the base floods on the peninsula ranged between about 14 and 18 feet. So we have a lot of structures that were below that before Ike, and they got completely knocked down.
And a
So,
lot of
especially in
old
the Gilchrist
telephone,
area,
a lot of old telephone
yeah.
poles too.
Right, they were really low too. I mean, a lot of people that were building back after Ike, they had homes that were, 8, 9 feet off the ground, and they were going at 14, 15 feet off the ground to get above the flood elevation. And so it made a big difference in one, how the house felt when they were in it, because it
Hmm.
still is going to move a little bit. But it also was, a lot more stairs to climb. But it got the house up over that flood elevation, which was really the critical element. Because, like I said, we can design for the wind part. It's just that flood element, and then some of those unknowns, like, are we going to get a tornado? Are we going to have really high rip currents in certain areas that are going to really put some extra load on some piles, or push debris into the house or something? So those are some of the main things that were differences. And last week, if you looked at the NOAA, I mean, it was like a hotbed out there. I mean, there was five different things going on
I
all at one
know.
time. You had Idalia going in one way, and you had storms coming our way, and out towards out in the eastern Atlantic. So I mean, there was a lot of stuff going on. So you really just never know when we're going to get something. I mean, we may go to sleep tonight and wake up and there's something ready to pop up and hit us in 2 days. So you just kind of have to stay in a state of preparedness this time of year.
When we have a storm, whether it's here and y'all have offices all the way into Florida, when we have a storm, do y'all go in and say, okay, we had a 10-foot or an 8-foot storm surge on this one? And do y'all look at the damage and study it to see what you can do to better it? I know, like during Ike, we had a lot of undermining where the water rushed under
Mhm.
the house, ate away from the pilings, and then a house on telephone poles floated by and crashed into it. Do y'all learn and use some of that information going in to building houses and what you need to do?
Yeah, we're really lucky. So right after Hurricane Ike, we actually had a team, a mitigation team from FEMA that came in and met with us, my dad and myself, and they wanted us to take them to certain houses so that they could see damages, and so they actually wrote an assessment report, and they did that exact thing. They did that evaluation. So we were kind of like the boots on the ground, and we took those teams out there to see what that stuff really looked like and how it performed, and then that helps us make better engineering decisions, better code decisions as we move forward with design. It helps us make better decisions on what performs well and what doesn't, because everything works with the math, right? But when you get it into real world, you have to take a lot of other factors into account. So it just really helps to be able to see those failures, see why things fail, and see if we can mitigate those for future events.
How much did you? What's one of the storms that y'all have learned more than anything from? Was Ike a big learning curve for y'all, or was it Katrina and Rita?
Well, Katrina and Rita, like Katrina was, you're
It
not
was
going to
more of a
learn.
flood event,
It
wasn't
was
it?
more of a flood event, and a lot of it was because of the levees and everything. Now, it was a huge storm, and it did push a lot of water in, but it was more about the flooding and the damages from the flooding. So it was hard to really assess. There were so many that were just complete, what they call slab claims, total losses. You really couldn't really evaluate, was that wind or water or what things kind of contributed to that. And there were still quite a few of those in Ike as well. But Ike, because it was in our backyard, we were able to really get involved in a lot of the damage assessments. And actually, last year after Hurricane Ian in Florida, I spent about 2.5 months in Florida doing damage assessments to see how things performed, why things did well or not well. And that was a really high wind storm, but it was also a big storm surge flood as well. So it kind of mimicked Ike in those ways, and it in a lot of the things that we saw, a lot of the damages that we saw in Fort Myers Beach and in Sanibel Island, those were the same types of damage models that we saw during Hurricane Ike, because the structures, a lot of them were older, lower, not up to flood code, didn't have deep piles, really didn't
Hmm.
have great maintenance maybe. So we saw a lot of the same things happen, and I actually brought out a lot of my younger engineers because I'm like, you're never going to learn this kind of thing sitting in an office. You have to
Right.
go out and look at it. You have to see how things fail. You have to see what does well, and then it helps you make better engineering judgments as you move forward in your design.
What's the biggest thing you've learned from, one of the big storms, maybe the one in Florida or the one or Ike? What's the biggest thing that really surprised you that you've learned from some of those?
It's just so funny. Like, you think that you've can pick and choose, like, what do you think is going to perform well and what isn't, and you're always going to be surprised by something. Something is always going to not go the way that you thought it should go. And I've seen so many. I've seen entire roof systems split into houses. I've seen, boats in the sides of houses. I mean, you just never know what's going to cause a failure, and so you get a lot of undermining. Depending on how those rip currents run
Hmm.
through there, you might start getting a lot of undermining in an area that it really wasn't supposed to have that. So if you may have something that's blocking the flow of water, then it's going to change that path. So you may have somebody decide to bring in a big shipping container and stick it in the middle of, somewhere, and
Right.
it's going to divert the water differently than if it could just flow the way it's supposed to. So there's just a lot of different things that contribute to that. So one of the things, though, people, when they're trying to, say we look up tomorrow and we see that there's a storm, what are we going to do? I mean, obviously we all know to pick up our loose items or put down our shutters, or make sure our impact windows are okay. But one of the things that we've learned is that the biggest problem that we have is from pressure changes inside the house. And so you'll start getting some suction on the roof and suction on the walls. And the best thing that you can do is shut all your interior doors. Because what happens is, if you start getting those pressure changes, instead of that pressure change being in a huge room or all through the house, it kind of gets contained to that one area. So it doesn't spread, and it kind of contains that pressure, that if it's maybe a high pressure on a corner or something, instead of it spreading through the whole middle of the house, it maybe just stays contained in that one area. And also, if you have a breach of some kind, say if you have a window breakout or something, the loads are kind of contained to that one area, versus if it's all the way open, it could just take the whole roof off. So um, just something as simple as shutting all your interior doors when you're leaving could really, contain all those pressures if you do have a breach in your house. And I think one of the other things too is that, people don't realize, they'll leave for the weekend and think, oh, I'm not going to shutter my house. Well,
Hmm.
it's really important to stay prepared, because if you may have impact windows and doors, and that's great, and then you don't have to worry about it because you have that protection built into those components. But the likelihood of you being able to get all the way back to shutter something in the time frame that you need to do that and protect yourself by being gone is, you might be putting yourself at risk. So I think, I always advocate for people to use impact windows and doors, because especially for homes that are vacation homes, not your primary residence, or if you're getting older and you don't want to have to be lifting,
Hmm.
toting, hauling all those panels and stuff, on a second or third story.
Yeah.
you know, you definitely want to have that built into the windows and doors. There's also another misconception about impact windows and doors. They feel like they can't break, but it's kind of like your windshield. When you get in
Hmm.
a wreck, your windshield will shatter, but it stays
But it won't
together.
go.
And so that's kind of the same thing with impact windows and doors. They may break, they may shatter, they may scratch, but they're supposed to keep your home from breaching and have a big hole in the side of your house. So um, ideally, my dad says belt and suspenders, so have the impact protected windows and a shutter
Right.
system because you have both layers of
Both.
protection. But if you don't have that opportunity, that if you at least have one or the other, if you have a shutter system you can deploy every time you leave, or impact protection built into your windows and doors, either one is
Right.
a great option.
I've always thought about under the house, get rid of everything. We've put deck chairs when we've had
Oh
close
yeah,
calls up on the patio and tied them together, screwed them down, because I want everything to flow through,
right,
under my house and be gone when I get back. I'd rather, you know, uh, lose some stuff or have a
right.
free flowing under the house than, if you have a garage downstairs, is it good to open the garage door or should you leave it closed so
I
that
just, yeah, open it,
open
100%.
it?
Because this is the thing, you're trying to prevent loads from pushing on those piles, and if that door is closed, I mean that's supposed to be a breakaway wall. Okay,
Right.
and I know that most everybody down there that has breakaway walls has done something to make them less breakaway than when I saw it the last time. Okay,
Right.
so if they put up shelving, they've finished out something on the inside, they've done something to
Hmm.
make it more rigid where it is not going to perform as well. So if you can open up that door, remove any of those obstacles out of the way, so the breakaway walls can perform as intended, where they can actually, because what we want is to save the structure. We
Right.
can build those. Those are
It's
sacrificial.
nickel
We
dime
want
you're saving
to
there.
exactly, and none of
Yeah.
that's covered by flood insurance anyway, because anything below the flood elevation is not covered by flood insurance. We want to build it the cheapest way possible. We want it to break away. We want it to preserve the main structure. So we definitely want those to break away, so that, because if it doesn't break away and it just
Pressure.
starts pushing and pushing and pushing on those
Hmm.
piles, it could break the piles and collapse the house, and we do not want that.
If we had another Ike, uh, you've, Aaron and Franklin's been a big part of the rebuild down here. If we had another Ike, same storm surge, same everything, what do you think the impact would be down here? Would we still see the beachfront homes torn apart, but a lot of the other homes in the subdivision survived to where they didn't? Because we've gone back and rebuilt more or less three-quarters of the homes down here since Ike, and I think we're past now maybe the number of water taps we had down here pre-Ike,
Yeah.
and it's still growing. But what do you think the damage would be? I know we're going to lose garages and stairs and
Sure.
electrical, meters and stuff. But what about homes? Are they built back to where if another Ike came in, we'd be sitting pretty good?
I mean, I think you're going to have a few one-offs that are going to have some kind of loads on them that we could not predict. But I would say for the most part, the home should perform really well under the same conditions. I mean, we have them higher above flood elevation. We have them designed to the better flood code, where you're getting the higher water impact loads and everything. And we're designing them with, make sure that the walls are breakaway and they're in good repair. They're younger homes. The inventory is just younger, so they don't have the maintenance issues that you have in the older group of homes. So I think overall, I'm going to sleep just fine when those,
W-
if we have the next storm.
One of the big changes we've had is the elevation the homes are built. Has there been that much change in how the homes, once you get above that flood elevation, have has there been much change on how the homes are put together as far as strapping and material that makes them stronger too?
That part, it pretty much just stayed the same. I mean, the design criteria changed just a little bit. They changed the wind maps about a few years back, and while the wind speeds went up, I mean, it's like y'all are probably at about 149 or so miles per hour. What they did was they also changed the formula which you use to calculate the pressure on
When
the walls. And so the pressure from a 130, which is what we used to be, to a 149 is about the same.
hmm
The windows and door pressures are about the same. The wall pressures, we still do the continuous load path where all our clips and straps. We still do our sheathing. So all those things are still the same. I would say the biggest change is the fact that we're getting those houses above flood elevation by anywhere from 2 to 4 feet, and that is making a huge impact. Now, just think about it. You've got a tree. Your piles are big trees, right? And
right,
so that tree has a certain amount of deflection that is, allowed for that length of a pile. And so as it gets taller, that tolerance gets more. Well, that may not be your tolerance, and
right.
as you go from a 10 foot above flood to 15 foot, I mean, that's a big difference. So that's why we do some knee bracing and things like that. And we actually had a client a few years back, and the lady, poor thing, she had vertigo really bad. She couldn't handle any kind of movement in the house. So we ended up putting a lot of bracing and stuff in there to take out as much movement out of that house as we could, because she had gone from a house that was about 8 foot up to one that was like 15 foot up, and it was
Yeah, it
tremendously different.
used to be you couldn't back a truck under your house. You
Right.
parked in front of it, and now you can back a truck. Well,
With a boat and a RV and
right. And we did see during Ike, boats that were tied off to pylons that went up through the floor and stuff. And so,
hmm
you know, I tell everyone when they call for a voluntary evacuation, I pack up computer monitors, sound equipment, everything I need to operate. I would
right.
rather haul it out and haul it back in. In fact, for Laura, I did,
hmm
than come back and nothing's here. If people want to get hold of you to talk about maybe your strong home inspection program, or they're looking at building a home because y'all design homes, you do the engineering on them. What's the best way for them to get hold of you?
Well, you can always you can either call our main office in Texas City, which is 409-935-5200, or you can just go on our website at aranfranklin.com. It's ARAN Franklin.com.
Cool. Well, that's great. Well, we'll be back here in a week or so with another show with Chandra on TWIA on home inspections. In fact, I think I'm going to corner her to go in depth into the strong home inspection program. What makes a home a strong home inspection? Because and I want to talk about this too. The discount for insurance is unbelievable, and it's actually worth doing it depending on the size of your home, from what I've heard. And so we'll dive into that. Chandra, thanks for joining us
Yes.
today. We're going to head on out. Until next time, I'm David with Bolivar Live. Y'all have a great day, great week. Come see us. God bless, and bye bye.